Any good discussion about disaster recovery is going to eventually lead into your backup strategies. What we've been focusing on mainly up until now is how do you configure replica sets, and with the last module, the sharded cluster components, for decent disaster recovery, decent levels of failover based on your guiding principles. The other component to that, though, is what if that stuff doesn't work? What if you still end up with corruption? What if you still end up with failed systems? What if, despite the best intentions in the world, you still end up in a scenario where everything's broken? What is your strategy then? Or even if your other disaster recovery strategies are actually working, how do you get the thing that failed, the thing that's broken, the thing that put you into a failover scenario in the first place? How do you restore it and get out of your disaster? How do you restore it and get out of your failover scenario? And often the answer to that is your backups, and your backup strategy will play a huge part in determining how quickly you recover from any given failure, how completely you're going to recover from any given failure. In other words, is there going to be any long-running fallout? Is there going to be any long-term effects from a failure, from a disaster? And then in addition to that, the effectiveness of your backup strategy is going to play into and feed into your disaster recovery strategies. If your backup strategy is absolutely fantastic and you know that within 5 minutes of a complete failure of your entire prime or hot data center, that you've got an off-site backup you can restore from and have everything up and running on a pristine new data center within 20 minutes, then that gives you some very interesting options from a disaster recovery perspective, especially if 20 minutes is within your acceptable amounts of downtime. That's quite an impressive backup setup that you would have to achieve something like that. It's not beyond the realms of possibility. So again, backup strategies and how you implement your backups are going to have a cost component, they're going to have a business requirements component, they're going to have a performance component, and they're going to have a disaster recovery component, how they feed in there. So it's not, again, similar to our disaster recovery strategies, it's almost always a little bit more complicated and a little bit more complex than it appears on the surface. However, there is generally one statement that I'll back in almost all cases. Are backups a good idea? And the answer to that is a resounding yes. Yes, they are. Almost regardless of how good a particular backup is, or how long it takes, or those other various pieces that make up a backup strategy, almost regardless of the answer to those, the answer to are backups a good idea is yes. And this doesn't just apply to production systems. This applies to your own laptop. This applies to your own company's data. Backups are almost always a good idea. It's very rare that you're going to run into and say, oh no, I backed that up too often, I feel bad. The only concerns that do run in terms of backups are they're not free. You have to have somewhere to put all that data, you have to have some way to pull it all back, and there is a cost associated with it. So are backups always a good idea? Yes, absolutely, but they are not free. So let's talk about some of the sort of considerations that you need to think about generally when you're implementing a backup strategy. The first one is generally how quickly can I restore from the backup, and does that meet my requirements? If it's going to take 3 days to restore from your backup because it's offsite on a tape that's tough to access, or you've got to send someone out there with a flash disk to read it off and then bring it back, load it back up, is it worth having? But 3 days from now you might be out of business. So you have to consider how quickly you can actually restore from a backup, and does that actually meet the requirements that you have from recovering from the sort of the scenario where you're having to reclaim data from a backup or restore a system from a backup. The other consideration, and one that permeates through all good software delivery and operations best practice and everything else, is test your backups often. You can imagine that if there was some sort of issue with your backup process that was introducing corruption, you're storing snapshot after snapshot, you think, great, I'm taking hourly snapshots, the most I'm ever going to lose is an hour, and probably less than that. You know that you've got a nice fast connection back to your backup solution, so you think that you're going to be able to restore in a matter of minutes. So far so good. However, you haven't tested, and what's happened is there's a bug in the backup software, or there's a transcription error, or the compression algorithm that you're using is faulty. And what happens is that the data that you've backed up is bad. And when you go to restore it, it restores in 2 minutes, 5 minutes, whatever the actual completion time is for it, and the data is corrupt and unusable. And you've basically been storing garbage for the last 2 years because you haven't actually tested the backup and restore process. So always test it, restore, and run. from backups regularly. And then the final consideration is coordinated backups are difficult. What do I mean by that? Well, distributed systems make taking a consistent backup across, let's say it's multiple servers, a tough prospect. How do you make sure that the backup that you're taking at that particular point in time is the same point in time across multiple servers? Even with something as simple as using RAID, which we covered in an earlier module, how do you make sure that you're actually getting a full stripe across multiple disks when you take your backup? So once you get into the scenario where there are multiple hosts, multiple processes, multiple applications, multiple disks, you start to get into more thorny backup problems. So whenever you're going to back up a distributed system, you have to kind of ask yourself, is this going to be a usable and consistent snapshot or backup of the system that I'm backing up? Will it work? Or am I going to run the risk of having an inconsistent system when I try to restore? And this feeds back into your testing. When you take this backup and you're taking it every hour, every day, whatever your requirement is, when you restore from it, is the data that you're getting back in a sane state from the view of the overall application, from a view of the overall system? It's similar to the kind of argument you have when you run the likes of a file system checker in Linux or our very own repair command. Those things will check to make sure that the structure of the data works, but the fact that you're getting a valid data structure back and that your program doesn't crash, your operating system doesn't crash when it starts, doesn't mean that all your data is actually the way you expect it. So you need to have that sort of view. Once I'm restoring from this backup and I'm restoring to these multiple different components, am I getting a consistent and sane view once I do the restore?